We go into the second part of this presentation held by Andrea Friso. He is the R&D manager at Legor Group for Master Alloy Business and has a strong experience in precious metals metallurgy and its relationship with jewelry production processes. He coordinates the conception, testing and release to market of new Legor alloys and constantly supports technical sales teams in Legor worldwide. In his presentation, he continues talking about binder jetting and the comparisons with existing jewelry processes. The presentation is focused on introducing the binder jet technology in its applications for jewelry making and showing results from 10 months of use of this technology at Allegro laboratories in Bressanvido, Italy. Practical experiences of testing and production using binder jet will be shared during the presentation in comparison with other and still better known technologies. Thank you.
Buongiorno a tutti, noi ritorniamo in italiano.
Good morning, ladies and gentlemen. I'm now going to follow suit to what Alejandra de la Rica had just said to us. We're going to get further into detail when it comes to gold jewelry and the fashion industries to see how this technology can be best used for these industries. So today's objectives have again to do with the binder jet technology in its applications in the world of fashion and gold jewelry. To this end, we are going to present comparisons between the different technologies being used in the industry, and then we're going to see the results as obtained in our experiments, the experiments that we carried out as our labs. First of all, why has Lega opted for the binder jet technology? Well, because it combines the best of some of the additive technologies already in use. So when it comes to the manufacturing of minute parts and jewels, such as SLM and MIM, I greatly appreciate the description by which binder jet could be digital MIM, whereby basically we can shift from CAD design to the finished product in no time, as is typical with SLM, with a high productivity rate and good quality standards, as we find with MIM, metal injection molding. Binder jet grants a number of advantages in that the surface roughness is lower than that which go with other additive manufacturing technologies. There's no need for supports that use up additional material, which is again another very interesting finding when it comes to precious metals indeed. And then this technology is one which uses up very little powders, because the powders basically can be reused at the end of the cycle. So these features combined with a number of assessments that we made on the results of the experiments that we carried out persuaded us onto carrying out further experiments with this equipment and to buy 2 prototype units that are equipped with all what is needed to manufacture finished products. Between March and September, we've optimized, we've used basically the material, which is a steel, and we've used this steel basically to get better trained in using this piece of equipment. The final objective was to use materials that are better familiar to us. Obviously, jewelry is our core business. So as from November, we've been using bronze, silver powders with the sintering processes and printing processes to better use this equipment. As for the technologies that we wanted to compare binder jet to, because we believe that there are technologies can be replaced by binder jet. But the first that I can think is microcasting. Microcasting is perhaps the process which is best known when it comes to jewelry and gold jewelry making, which is off the shelf. Again, of course, it can be used for any type of metal used in jewelry, and it grants also a very good roughness of the object that's cast. And this is something that we want to consider because this requires also a better reduction in size, in that we're going to use also less material in the polishing stage, in the finishing stages. We know that microcasting has one major issue in that it is very much an empirical process. It is very much operator dependent. It very much depends on the skills of the operator in stabilizing also certain processes, certain dynamics. And you have to carry out a very accurate process also in looking at the defects when it comes again to microcasting. And the environmental impact is certainly most relevant because obviously the investment is to be, there are fumes that are generated because of the burning of resins. There is a silica to be dealt with, of course, when the investment is removed. Because of all these issues, again, the process is not very green, basically. SLM. Selective laser melting is the other technology that we've compared printing with. This is the technology that enabled the gold industry to shift from the design to the manufacturing. This is certainly very practical to the development of prototypes. A small series, basically, of products. It allows for a very limited reduction in size after the finishing of the piece. It is very suitable to have a unique piece, again, available immediately after having the design of it. When it comes to productivity, when it comes to precious jewels, selective laser melting requires a certain amount of material to be used, and obviously this has to be in line with the investment that we wanted to make. There's a certain speed we can produce at to grow and have a good quality of the product. So sometimes laser has to be used repeatedly on the same edge, on the same side of the object, so as to reduce roughness at best. And this, in a way, reduces productivity because it adds on time. There's an additional aspect that of reusing supports and powders, which obviously can add to the material being consumed. MIM, metal injection molding. Well, this is a process that we don't use for gold jewelry making. It uses plastic injection printing technology. We use metal powders that can be binded up together with a polymer that can be cured up, heated up, and then be made printable within a mold. This technology is marked by a very high level of productivity, and it is highly automated as a process. So it works very much for mass production because it requires little labor, low human resources basically to operate it, and it manufactures at very high speed. Yet there is a problem in that molds are to be developed, and those may be very costly. They could cost up to thousands or up to 50,000 euro for one mold just to have one single object. And it is a subject to important reduction in size. And that could be is an issue. There is also problems also in terms of the undercut, so you cannot have a complex items because again the undercuts are not admitted. So we don't use this technology for gold jewelry making because with gold jewelry we have non-standardized products. It is not a mass production. As for CNC devices, well, CNC works very well when it comes to using little tolerance object. This is why it is widely used when it comes to watchmaking. The watching industry requires assembling different parts to have a final element, as for example, a bracelet. It can be used for different metals. As a matter of fact, usually CNC are used when all semi-finished products are already added. So with microcasting, you can have problem with so you don't have any problems with the materials. But if
che è impegnato, chiaramente non posso sostituirlo fino a che non ho completato la mia produzione,
it can be
quindi
difficult to use
ovviamente
it at the
è molto alto invece lo scarto.
there may be a lot of waste, and it could be because of the lathing stage, or sometimes that waste can be cast, but there are maybe other powders that actually cannot be reused. So again, the problem with CNC is that a lot of waste are generated. Not all of these can be reused. Another aspect I was hinting to earlier on, and that is the management of a workshop. For when I use this CNC equipment, I have to understand what is the mindset again behind this. I have to have tools, I have to have specialized resources. So with BinderJet, as with this, you basically have to understand how it works. You have to understand what are the strengths and weaknesses accompanying the individual technologies.
Già li abbiamo visti nella precedente presentazione, però appunto la massima flessibilità.
We've heard that there's very good flexibility with BinderJet, similar to SLM, and this is a great strength for the BinderJet technology. Another important strength is that there is a medium to high productivity, because on the bed you can have different objects with different tolerances, with different shapes, and then you can work with different layers. So you can work with different levels. Again, you can work with different items for the BinderJet. In the world of jewelry, this is a little known technology. Even the costs connected with this technology is very high. The investment is quite relevant. There are aspects to be considered, as for example, the risk of geometrical deformation when the sintering is entered into, or the reduction in the size that can be different at different sides of the objects. With reference to productivity, we have identified certain values as to rank the different equipment for the manufacture of one individual item. An item that could be of interest for the gold jewelry industry or the fashion industry in this case. Metal injection molding, MIM, ranks first, because with this object you see that with 4 hours you can obtain as many as 3,000 items. The cycle of 2 days, well, the first day can be used for the printing of object, and subsequently the sintering is to be performed that can take as much as 10 to 15 hours with the different steps from green to brown to sintering itself. With microcasting, you see that the productivity is halved vis-a-vis metal injection molding, And it requires many more working hours. In this case, indeed, as many as two people are required, one devoted to the waxing and one for the casting. And then mass production can be obtained for a number of trees. So in 2 days, basically, you can have as many as 3,000 items. This is the estimate that we arrived at for
Nel momento in
this
cui si
microcasting.
arriva a invece,
In
per
the
quanto
case of
riguarda il binder
binder
jet,
jetting,
operare una serie di cicli di stampa e
you can
arrivare a
have
saturazione di un forno, almeno con
you can
dispositivi che abbiamo in casa,
fill in the
e
furnace,
nell'ambito di una giornata
and
si può
for in
ottenere
2 days
all'incirca 2000
you
pezzi.
can have
Quindi
as many
sono
as 2,000
un
items.
ciclo intero di
So
sinterizzazione
this
che
would
va
require this is similar to one complete
tutto a
cycle of
seguito della
sintering.
fase di stampa e
One
del fatto
cycle of
che
sintering is to be
per
carried
quanto
out
riguarda
after the
invece
jetting.
un pezzo che
The
venisse fatto in
powdering also has to
CNC
be included. In the
partendo da
case
un
of
prelavorato
CNC,
tubo,
starting from a
comunque ore
semi-finished
uovo
product
nell'ambito di
with
una
8
giornata
hours
lavorativa abbiamo ipotizzato una produttività
of
di circa
work,
100 pezzi,
only
che è
100 pieces can be
superiore alla
obtained,
selective
which is
laser
more
melting,
than can be
comunque un
obtained
ordine di
with the selective
grandezza
laser melting.
superiore
But
rispetto
certainly it
alla
is a
CNC.
completely different order of
Questa
magnitude if compared to binder
capacità
jetting.
produttiva del
So
binder jet, pur
binder
non
jetting
appare come tale
has
tecnologia,
a
per
pretty
un
high
aspetto comunque rilevante, interessante per soddisfare
productivity,
le nostre
and that
necessità.
makes it very interesting for our
Altro aspetto
processes.
interessante è
Another
l'impatto ambientale,
important aspect to be
detto
considered is the
come
environmental
avere un
impact.
impatto
We've already said
ambientale
that
molto alto,
microcasting
sia per
has an
la
important
quantitativa
footprint on the
materiale che va
environment because of the amounts of material
sottostanzialmente
which is wasted. As in
considerando
20% can be
che abbia
considered
subito
as
questi
connected
diffusori,
to the
ma
bottoms of the
sicuramente gli
sprues.
access smaltiere
And there are
e i
also
siti di
investment to be
decontaminazione sono rilevanti nell'ambito di una gestione
disposed of, and this obviously
si
bears
scende poi
importantly on
con
the
il
environmental
CNC che ha un impatto
footprint. With
ambientale più
CNC,
basso,
the
soprattutto per la grande
footprint is
quantità di
lower,
chimici di lavorazione
but yet there
sostanzialmente
is a lot
e
of waste which is
quindi
generated.
agli oli emulsionanti
Also because of the
utilizzati
oils that are used
sottoposti
and that are to be disposed of
e
after a certain
a
number of
seguire poi
cycles.
tecnologie più green, potremmo dire, come
Now,
appunto
a greener
l'SLM che
technology
ha
could
sviluppato
be the SLM,
a fronte di una resa per ciclo produttivo molto bassa,
which
perché
has a
comunque
low
devo
yield
riempire
because
il
I
volume di
always have
stampa
to
con
fill up all the volume with
puoi ottenere
powder
soltanto il netto degli
to
oggetti o
obtain all
comunque
of
un
the a net,
80%
and I
sono
have 80% of
utilizzate
the powder
esclusivamente
that I use, with 10% of
e quello che
supports
penalizza l'SLM è semmai la
being
produttività
obtained,
bassa
and there's low
di ogni
productivity
pezzo, costa di
accompanying
più
SLM, so
di
each
l'impatto
item
ambientale.
basically
MIM
bears
e
more on the
Binderjet si
environment. As for
differenziano
MIM and
principalmente
Binderjet,
perché
well, the difference between these
MIM
two
ha ancora necessità di
are the
unità
following.
finali
MIM still requires
non dello
some
stampo, quindi questo
um,
10% che vedete
feed.
di
There's
materiale da
10%
affinare
of
è
the material
sostanzialmente quello che poi va tagliato per
that is
ottenere
wasted
il
because
progetto
it is
definitivo.
removed to come up with a
Polveri
finished product.
riutilizzabili
The
invece
powder that
nell'ambito
can be
del
reused when
Binderjet
it comes to
sale
binder
al
jet printing is as
85%
high as
perché comunque io ho una
85%
resa
because
più
I
alta
have a
del
slightly
fatto che
higher
sono a
yield. I
filetti
can work at
e
different levels,
comunque
as we
questa
said,
polvere può
and the
venire riutilizzata
powder
per
may be
secondo tempo
reused later on, as we've just seen.
quindi per quanto riguarda poi la parte sperimentale abbiamo scelto
As
una
for
serie
our
di
experiments,
oggetti,
we
ovviamente
have chosen
nei primi
selection of
mesi di lavoro
objects.
abbiamo
In the first months, we
provato
have
con il
printed
collega Lago
with
una
Lago,
serie di pezzi
Mr. Lago, my colleague.
di
We've
forme
printed
e
a
di
number of
difficoltà anche
items of
crescenti per
different
ottenere
and
poi
increasing
delle valutazioni
complexity
inizialmente
to come up
qualitative
with a
e
number
poi
of evaluation
interazioni
on the
relative a
quality-wise and
misure e prestazioni di questi
quantity-wise,
oggetti in modo da quantificare come dire,
so as to come up again to
un'indagine
some kind of a
qualitativa e
comparison with our
quantitativa
survey,
su questi
measuring the quality
aspetti,
and
mentre il
quantity
confronto
of
con vari
in our
oggetti
products
prodotti con le
as
altre tecnologie che abbiamo
comparing the different technologies available
sviluppato.
at our
Inizialmente lo studio è
workshop.
stato fatto
At the
solo
beginning,
appunto su AISI 316,
we
si è
only
poi
used
seguito un
one type of steel,
approcciato
AISI 313, then we used another type of steel,
mancanza di questo elemento e seguono, sono attualmente in
And then we're still carrying out further tests on using bronze and
Quindi la
925
procedura
silver.
di indagine ha visto chiaramente delle indagini qualitative sull'oggetto
Qualitative
come
tests have been performed
specificato e poi si è
on
passati
the sintered
di
object. Then we
analizzare
looked
altre
at the
misure
digital
di rugosità
microscopy.
su
We
diversi
measured
livelli di
rugosity
crescita e
on
delle
the different
indagini
level
di
of the,
porosità
and we
residua
looked at the
sui
residual
pezzi,
porosity on the
tenendo
items
conto che questo è
produced,
un indicatore anche della qualità
because
superficiale.
certainly this has
Se il
is an
pezzo
indicator
con
of the
l'utilizzo di
surface
tecnologie
quality.
meccaniche, la presenza di pori
In the
all'interno può
case of
ridurre
pores, for
problemi di
example, we might
rotture
have
o
problems leading
diminuzione
to
del
fractures
distretto
or
fatica
reduction
nell'ambito della
of
gioielleria. Questo non è
strength. In the case of jewelry, obviously,
ragionevolmente nella maggior parte dei casi il problema,
this is not
però
pretty
è
much the
comunque un
issue, but
indicatore di
it can be an
quanto
indicator, porosity again, can be an
difettosa può
indicator of the
essere dal punto
degree
di vista
of
di corrosione del
defects
singolo
that we may
cavità
have
superficiali
because
un
of
pezzo per
cavity,
cui una
because of defects,
porosità
because of
molto
dent.
bassa
So a
è
very
già un
low
indicatore di
porosity in
quello che
itself
troveremo
is
dopo
an
la
indicator of
riuscita
what
del
we're going to
progetto.
have after the polishing,
Allora,
after the
questa è
finishing
una
of
tabella
the
che
products.
non vediamo ogni singolo
Now, we're not going to
dettaglio,
analyze each
si
every detail of this
trovare
chart,
poche
just look at
righe.
the first
Come
lines.
riferimento di qualità accettabile per il mondo del gioiello o
An
della
acceptable
moda,
quality when it comes to
indichiamo
fashion and
una
gold jewelry
rugosità sul
industry, well,
pezzo
roughness
lucidato
on a
inferiore al
polished
micron, quindi
product should be
effettivamente
lower than 1 micron, so
0,7.
0.6, 0.7 would be acceptable.
Il confronto è più interessante ovviamente nel momento in cui il pezzo è S-cast oppure
But looking at the
S-sintered,
item as a sintered or
relativo
as
di
cast, so
passaggio
before the
successivi
finishing,
produttivi
basically
su una
steps,
media di oggetti che sono stati
on an
indagati
average of
in
items
zone
that have
diciamo
been assessed.
comparabili, per cui con planarità in cui la misura potesse venire fatta facilmente, abbiamo individuato
We've identified
il MIM come la
MIM
tecnologia
as the
con
technology which is accompanied
superficialmente
with a
bassa
lower
pressione, aspetto che
superficial
probabilmente
roughness,
dipende
which
dalla pressione
possibly
utilizzata
depends on the
sarà
pressure which is
compatta
used in the
ulteriormente
mold,
il pezzo,
compacting
si vede magari
the
possono rimanere
item.
una porosità interna più alta
There
per
could be
alcuni
a
pezzi che ci sono
higher
stati portati
in the
in
porosity
seguito poi dalla
yet,
microfusione
and then
e
we
comunque con 2
with
micron
microcasting
diciamo che la rugosità da sola
had
spiega come sia appunto
similar,
la
granted a similar
superficiale,
roughness,
ma non
superficial
presenza
roughness.
di discontinuità multiformi come possono essere porosità o altre difettosità.
It was
Nel
not
caso
accompanied by
dell'acciaio,
other defects. In the case of steel microcasting,
lavorando con parametri anche diversi, ha rappresentato un po' una sfida per cui
was pretty much
i pezzi
of a
avevano
challenge.
dovuto
Indeed,
essere
the porosity
considerati
of
considerabili
the products would
processo
not be acceptable when it comes if those items were thought of for the gold jewelry.
molto bassa, per cui abbiamo ottenuto una porosità ampiamente inferiore allo 0,5,
We also had a very low porosity with SLM,
e con una rugosità superficiale di
with
4
the
micron,
surface roughness of 4 micron,
confrontabile con quello
which doesn't compare with the one of microcasting, but still it is much lower than the one we saw
trattati con l'SLM,
with SLM, where the roughness was higher
ai 10 micron.
than 10 microns.
Altri aspetti appunto rilevanti da questa tabella sono appunto quelli dei cali dimensionali, per cui
The reduction in size is also to be considered. With MIM, we have a reduction in volume of some 20%. In the case of the binder jet, we saw that this reduction in size depends on when the binder was added to grant the adhesion among the different layers of powder, and this is something that should be considered again when the item is, when the project, when this jewel is designed.
nei pezzi delle prime prove, sia appunto gli aspetti di tolleranze, sono stati poi iterativamente risolti
We solved many problems repeating the test and sometimes redesigning the item with adequate software and CAD equipment, or with ad hoc supports that would guarantee the correct sintering. As for bronze, This is still a work in process. The roughness we obtained was somewhat less than 5 microns in the case of the product as obtained with binder jet, which is interesting but not low enough. The internal porosity is still too high, certainly through the sintering cycles, and this has to be reduced. In the case of bronze, microcasting was the technology that granted the best results with the roughness on the item as cast of 1 micron, which is certainly very attractive, and internal porosity that was extremely low, indicating that this type of material, such as bronze, is really perfect for the world of jewelry, because the best results were obtained again with bronze. Well, this is a bit too early to come to conclusions. It is a bit too early to say whether binder jet is readily available for the world of gold jewelry, because, well, the material is still lacking. There are specific alloys to be developed for additive manufacturing with binder jet printers. There are issues that are to be managed also when it comes to the management of so many powders, so we have to work hard over the next few months to develop adequate materials, so as to see whether, again, they can be best used with this technology, binder jet. Productivity is certainly very high, and we've also seen a good surface quality. Grain fineness appears to be compatible with binder jet. We can hopefully meet soon to see whether this technology can be used with bronze and silver, because tests are going to be performed, and then we're going to try and test also gold and platinum. These are the objectives that we set on ourselves for the future, so as to carry out a comparison again with the same technologies using the same material. Certainly, this technology probably is going to be added and not to replace other technologies, but this is something that we're going to see in the near future, hopefully. Having said as much, I'd like to acknowledge my colleagues, and thank you very much for your